117 tornadoes from one storm. One tornado can rip a house down to its foundation, twist steel like paper, and throw cars through the air. Entire communities can spend years rebuilding after just one. Ivan did that 117 times, and somehow, that still was not the most terrifying part. The people caught inside many of those tornadoes had already survived the hurricane itself. They had already endured 145 miles per hour winds screaming outside their homes. They had already watched floodwater swallow streets and neighborhoods. When the rain finally eased, they stepped outside and finally started breathing again. They thought the worst night of their lives had passed. It hadn't, and what came next would strike across 9 states at the same time. To understand what Ivan really was, you have to go back before landfall. The storm had started forming in late August when a tropical wave moved off the African coast and slowly organized over the deep Atlantic. By early September, it had turned into something extremely rare. Ivan reached Category 5 intensity 3 different times. It maintained major hurricane strength, Category 3 or higher, for 10 straight days, which at the time was an Atlantic record. Peak winds reached 165 miles per hour. Central pressure dropped to 910 millibars, the kind of numbers associated with truly dangerous storms. Ivan also became the southernmost Atlantic hurricane ever recorded to achieve Category 4 intensity at just 10.6 degrees north latitude. That detail mattered later because a storm this powerful traveling that far had enormous time to expand. By the time Ivan approached the Gulf Coast, tropical storm force winds stretched nearly 175 nautical miles from the center. This was not a compact storm. Its outer bands alone covered areas the size of entire states. And hidden inside those outer rain bands, something dangerous was already developing. NOAA Hurricane Hunter aircraft had been investigating Ivan during the afternoon of September 15th. The crews flew directly through the hurricane, dropping instruments called drop wind sondes to measure wind, moisture, and pressure through different layers of the atmosphere. Roughly 250 miles east of Ivan's center, those instruments detected a powerful band of thunderstorms containing embedded supercells, rotating storms capable of producing tornadoes. The Storm Prediction Center had already noticed the setup. On September 13th, 3 days before landfall, forecasters mentioned the possibility of isolated tornadoes across parts of Louisiana and the Florida Panhandle. That kind of lead time for tornado potential is unusual. Tornado warnings are normally issued only minutes before impact. The fact forecasters were discussing the threat days ahead showed how large and organized Ivan's rain bands already were. The first tornado watch was issued around 1 p.m. on September 15th. Less than an hour later, the first tornado touched down. 26 tornadoes occurred on September 15th alone. Families across the Panhandle were preparing for a hurricane, but tornadoes arrived first. The deadliest tornado of the entire outbreak touched down that first night near Blountstown in Calhoun County, Florida. Rated F2, it developed from a mesocyclone that forecasters at the Tallahassee National Weather Service office later described as nearly textbook in appearance. The tornado formed shortly after 2 a.m. local time. It crossed Highway 69, ripped roofs off homes, and tore through the Macedonia community. 2 mobile homes were lifted into the air. One was thrown across a roadway. Another smashed into a nearby house. 4 people died from that tornado alone. 8 others were injured. Nearby in Bay County, another tornado destroyed a wood frame home, killing the person inside. A restaurant and a real estate office were damaged, and 7 more people were hurt. Another fatality followed. By the end of that first night, 8 people were dead. The hurricane itself was still offshore, and another 91 tornadoes would follow over the next 2 days. Meanwhile, Ivan kept moving toward the coast. At 1:50 a.m. on September 16th, Ivan made landfall just west of Gulf Shores, Alabama, as a Category 3 hurricane with sustained winds of 120 miles per hour. Storm surge reached 10 to 15 feet from Destin, Florida, Westward to Mobile Bay. A gust of 145 miles per hour was measured in Wolf Bay. Offshore Noe buoys south of Dauphin Island recorded waves reaching 53 feet high, roughly the height of a 5-story building. Around 825,000 customers lost electricity. A quarter-mile section of the Interstate 10 bridge across Pensacola Bay collapsed into the water from wave action. Most hurricane stories would stop there, with the surge, the destruction, and the infrastructure failures. At the time, Ivan became the second costliest hurricane in United States history, behind only Andrew in 1992, causing an estimated $20.5 billion in damage. 25 deaths in the U.S. were directly linked to the hurricane itself. But Ivan still was not finished. In many ways, it was only beginning. Stories like this, disasters that hit twice in completely unexpected ways, are exactly why I built StormForge. If you enjoy deep breakdowns like this one, consider subscribing. Now back to what happened next. As Ivan crossed Mobile Bay during September 16th, tornado activity shifted farther inland. The hurricane's center was moving northward, but the right front quadrant of the storm, the area meteorologists recognize as the most favorable region for tornadoes in tropical cyclones, stretched across central Alabama, northern Georgia, and South Carolina. 32 tornadoes touched down on September 16th. In Franklin County, Georgia, an F2 tornado tore through homes and businesses, killing one person. Roughly 12 hours after landfall, Ivan weakened to tropical storm strength. Its enormous circulation was beginning to lose structure. By the morning of September 17th, the system had weakened further into a tropical depression over northeastern Alabama. Wind speeds had fallen far below hurricane force. On radar and in official reports, the storm appeared to be dying. This was the moment many people who had stayed behind finally believed the danger had passed. Winds had weakened, rainfall was easing. Families stepped outside, surveyed damage, called relatives, and started thinking about recovery. They were wrong, because the atmosphere was setting up for something even worse. Here is what was actually happening during the morning of September 17th, while people across the southeast began checking on their neighborhoods. As Ivan's remnants drifted northeast along the Appalachian Mountains, drier air wrapped around the storm's still active counterclockwise circulation. That dry air rotated toward the south and east side of the low-pressure center at exactly the wrong time. The skies partially cleared during the middle of the day, while solar heating was strongest. The ground warmed rapidly, and the atmosphere above became unstable very quickly. At ground level, this meant warm, moist air near the surface could rise explosively into cooler, drier air above it, creating the fuel needed for severe thunderstorms. Meteorologists measured this instability using CAPE, convective available potential energy. Ahead of Ivan's rain bands, CAPE values reached nearly 2,500 joules per kilogram, a significant amount of atmospheric energy, combined with strong wind shear caused by Ivan's circulation, changing wind direction and speed with height. The setup became ideal for rotating thunderstorms. But there was another problem that made this outbreak especially difficult to track. The tornado-producing storms were extremely small. Researchers later referred to them as miniature supercells. On radar, especially farther than 60 miles from a radar site, these storms did not look especially dangerous. They lacked the intense radar signatures typically associated with classic tornado-producing supercells. They were compact, fast-moving, and difficult to separate from ordinary rain cells. The National Weather Service office in Tallahassee monitored more than 50 mesocyclones during the 20 hours after landfall, rotating storm cores capable of producing tornadoes. Forecasters issued 130 tornado warnings. Only 20 later verified. That was not a forecasting failure. It reflected the reality of trying to nowcast tornadoes within a tropical cyclone. The storm cells looked different, moved rapidly, and often provided only minutes of warning time. 57 tornadoes touched down on September 17th alone. The highest concentration developed west and southwest of Washington, D.C., including suburban Virginia, communities not normally associated with tornado outbreaks, communities already exhausted from the hurricane itself, and not mentally prepared for another disaster. The National Weather Service office in Sterling, Virginia, monitored the storms as rotating cells appeared across the region. Tornado warnings were issued. Flights at Dulles International Airport were halted when the first tornado in the Virginia outbreak sequence touched down at 6:11 p.m. Airport operations stopped for nearly an hour and a half. At one point, the tornado threat became so close that employees inside the Sterling Weather Office had to leave their desks and take shelter themselves. Staff members near the windows later reported they could actually see the tornado outside. The meteorologists responsible for issuing the warnings had to run for cover themselves. The strongest tornado of the entire 117 tornado outbreak struck near Remington, Virginia, in Fauquier County. It received an F3 rating on the original Fujita scale used in 2004, meaning winds likely ranged between 158 and 206 miles per hour. The tornado reached widths between 200 and 450 yards and tracked for at least 20 miles across the county. 7 homes in the Meadows subdivision were completely destroyed. Another 18 were heavily damaged.